Hi there, and welcome to our Gatsby Conf talk, Building a Modern Front-End with a Legacy Backend. My name is Tom Hughes, and I'm a front-end developer from Liverpool in the UK. My colleague John Thornton is also going to be joining me on this talk today, and we're both the co-founders and developers at Attach Digital. Attach is a headless commerce agency that specializes in all things Jamstack with Gatsby. We build fast and scalable websites for modern growing brands. We've combined agency and in-house experience to give the best of both worlds to our clients and have grown organically thanks to good relationships and referrals. Since early 2019, we've worked with Gatsby as our core technology, allowing us to make the most out of the latest technologies for our clients. We also run 2 meetups for the growing Gatsby community, Gatsby.js Liverpool and Gatsby.js London, and we're currently organising meetups in both Liverpool and London for the spring. So if you're based in the UK, do keep an eye out and join the groups on meetup.com for updates. Over the last year or so, we've worked on a number of different projects involving legacy technology in some shape or form. And today we will talk about how we went about building a modern front end with a legacy backend. Here's John to explain more.
Thanks, Tom. As Tom mentioned, today we're talking about legacy software, so we thought we'd start with a definition. Legacy means denoting or related to software or hardware that has been superseded but is difficult to replace because of its wide use. A couple of key bits to start with here are superseded and difficult to replace. In an ideal world, superseded technology would be replaced. However, sometimes that's just not possible for many different reasons. So why not just replace it? These reasons, like many other things in life, always come down to either time, money, or both. We have a few examples here. On the time side, we have data migration, for example. In a legacy backend, there could be years of data which needs reformatting for an import to another system. Similar functionality. This could have evolved over years and require massive amounts of time to rebuild somewhere else, and have potential knock-on effects for other systems connected to the infrastructure. On money, we have issues like potential downtime, cases where companies might have lengthy contracts with current providers connected to their legacy site. So let's have a look at a recent project we worked on with a legacy backend, which is due to go live soon, a headless commerce site for SpaSeekers. SpaSeekers are the UK's longest standing spa booking agency, having celebrated their 30th birthday in 2019. SpaSeekers' current site, an ASP.NET monolith, was first built over 8 years ago, and the backend not only powers the website, but their CRM, booking engine, emails, and more. In addition to what the backend did when it was originally built, over the years more and more functionality has been added, so rebuilding this as part of the new project in one go was simply not possible. For SpaSeekers, with their current setup, they faced a few issues they wanted to solve. With the rollout of Core Web Vitals, SpaSeekers wanted a faster front end that would not only help boost their scores, but also make their site easier to navigate for users. As a team of predominantly back-end developers, SpaSeekers lacked front-end capacity and capabilities. And finally, due to their current monolithic setup, even a small front-end change would take a full deployment of the whole stack. So deployments would be less frequent because of time they would take and potential risks involved in doing that. SpaSeekers decided that they want to go more towards a microservice architecture, starting with a headless site and new APIs to support that site, and eventually splitting up the legacy backend into discrete deployable units to cater for different operations. Decoupling allowed for the front end to be built on a modern framework. Obviously, we chose Gatsby to help with SpaSeekers achieving faster page loads, better lighthouse scores, and lower bounce rates. Splitting the front end from the back end also allowed us and the back end developers to work alongside each other more easily, as we weren't getting each other's way. We could start on the front end while the GraphQL Content API was being built, and then once portions of that were ready, we were able to integrate them into the front end. The first stage of the build was to collaborate with the SpaSeekers team so they could get the necessary APIs for us to use. the main two being GraphQL Content API and the Checkout API. We'll start here with the GraphQL API. This was a large-scale build that was phased into different sections of the site content, like SPA page listings, individual SPAs, page content, and the blog, along with some reformatting the CMS, as the CMS wasn't quite intended to serve data this way. Being a phased approach allows both teams to align quickly on format and structure and speed up time in revisions later on. This was also split into a live and staging environment. And the beauty of the site being headless meant, as we mentioned before, we could start on the front end using static test data, being able to replace this quickly with real data once each phase was ready to roll out from the API. As we weren't using a third-party e-commerce platform like Shopify, the backend developers also had to build out a checkout API for us to interact with. This included functionality such as add to cart, postcode lookup, and booking generation. This legacy functionality has been built up for years and had many improvements bespoke to the SpaSeekers journey, which would have taken ages to rebuild and might not have even been possible with third-party integrations. We ended up building a lightweight, reusable context structure to use throughout the site, with a single Gatsby function to make the calls to the API, keeping this secure and scalable through Gatsby Cloud. With these new APIs, especially the Content API, we were able to provide data to the decoupled front end. With this, we had to find the best way to consume data. Back to Tom to explain more.
Thanks, John. Since we're using a custom legacy CMS, no specific source plugin exists. But since we're working with GraphQL, we could make use of Gatsby's Gatsby source GraphQL plugin. This official source plugin is versatile and allows you to connect any GraphQL API to Gatsby's GraphQL data layer. All we had to do was configure the source plugin in the Gatsby config file with a type name, field name, and the URL to query from. Unfortunately, with this plugin being so versatile, and not for one specific use case, there's no support for incremental builds, cloud builds, or preview. But we'll circle back round to that later. Since we weren't going to benefit from partial builds, and each of the builds would be a full build, we knew that build times might be a challenge, so we looked into different ways that we could solve this. At the start of the project, image optimization was discussed heavily, not only for the new site, but also for the current site. And as a byproduct of choosing an external image CDN, we improved build times as Gatsby no longer needed to process and optimize all the images at build time. We wanted a solution that worked for the current site, but also had good ties with Gatsby, so ImageX was a great choice. Plus, ImageX is actually used by a number of headless CMSs, such as Data CMS, Prismic, and Cosmic.js. So we were pretty used to their API and the functionality that ImageX provided. The integration between Gatsby and ImageX provides a few different ways to utilize ImageX's image API, so it's a good fit for most use cases. In our use case, we knew that the image URLs were going to come through GraphQL, so we made use of ImageX's Gatsby plugin image component. We created a UI component in order to set up a fallback image, as well as adding a couple of default parameters to send through to ImageX. Then in our component, in this case our contained image component, we made use of our image UI component and passed through the image URL and title, as well as the width and height and the type of layout. While there are some things that you can't do with Gatsby source GraphQL, there are some opportunities to increase performance, reduce build times. In the docs for Gatsby source GraphQL, there's some information about performance tuning with batching, and this ended up proving very useful for us. An environment variable exists to increase the number of parallel queries, and plugin options exist to fine-tune batching. While each use case is different and the appropriate values are dictated by the GraphQL endpoint limits, it's certainly worth experimenting with these settings, as we were able to shave about 60% off our build times. Gatsby v4 was released partway through development, so we decided to leave the upgrade until the end of development, or potentially even until after the site was live. However, the need for v4, specifically deferred static generation, came when around 200,000 extra pages were added to the build. These were mainly low traffic pages, most no traffic, that existed on the current site mainly just because they could. These pages were for package categories on the site and were effectively different combinations of package categories, locations, and state types. And these were currently being server-side rendered on the existing site. And while with v4 we could have also used server-side rendering for these pages, since the data was going to be the same for every user, DSG made more sense and gave us the best of both worlds, with reduced build times and pages that were still fast for the first user, but then SSG fast for others. So DSG allows us to defer building certain pages, often secondary or low traffic pages, until the first time a user requests it. And you can do this by adding defer true to your create page call in the Gatsby node file, or you can actually do this through the file system root API. The actual Boolean value you pass to defer can be based on your own logic, from basing it on the number of pages being generated, or even on analytics tracking. In our case, we're using DSG for package categories and passing true when they're not primary categories. We're also using it for blog articles when the publish date is before the cutoff date, which in this case is 6 months in the past. Now, since most of the 200,000 extra pages were secondary package categories, DSG actually got us back to similar build times to before the extra pages were added, just showing how useful this new rendering option is. Alongside working on Gatsby-related techniques to improve build times, the backend developers at SpaSeekers were also working hard behind the scenes, making incremental improvements to the legacy backend. An incremental migration to the cloud infrastructure with Azure allowed for scaling during builds, increasing the speed at which the database could be queried. Often as developers, we find ourselves looking for technical answers to questions, and, well, we probably overcomplicate things at times. And while Gatsby's different rendering options allow us to build out sites with hundreds and thousands of pages, one question we asked ourselves while implementing DSG was if all these pages were actually needed. And SpaSeekers SEO agency carried out some research looking at these extra pages in terms of traffic and links, and found that most pages were in fact not needed. This gave us extra options in our decision making.
So, looking ahead, we've been able to use some techniques to reduce build times. However, to make the most out of Gatsby Cloud, we'd ideally want to use incremental builds, cloud builds, and preview. To do this, we could look at building our own custom source plugin, something that will soon be getting easier with some new source plugin tooling on its way, so keep an eye out for that from the Gatsby team. Or we could potentially make use of many modern headless CMSs that are out there, in part or in full. The great thing about Gatsby is that we could choose to utilize a different data source set for, say, the blog, and give content editors an improved experience without actually having to change much on the site. So to sum up, there's good news. It's definitely possible to use a legacy backend with Gatsby. It may seem daunting, but with a solid plan, this is doable. With the Gatsby source GraphQL plugin, you do have to be mindful of build times, but as we've seen with what Tom's talked about, there are techniques to reduce this. And lastly, you can make incremental changes, and you can improve things in the future. You can even go one step further with incrementally rolling out the front end. For example, starting with the blog. Thanks for listening. We appreciate your time. Please do stick around for the Q&A where I'll be joined by Tom.
Don't miss the live Q&A coming up now.